This is day 7 of our CT review. Question 1 asks us to FOIL the following equations. So 3x times 2x plus 3x times 5 minus 2 times 2x minus 2 times 5 gives us this. We'll collect our like terms. Our 15x minus 4x becomes 11x. For a final answer of 6x squared plus 11 minus 10. Here we'll do much the same thing. We'll just use our FOILed method. First, outside, inside, last. Collect our like terms. X squared minus 12x plus 35. When given a question like this, easiest just to rewrite it as x minus 4 times x minus 4, and then use the same FOIL method. Collect our like terms for a final answer of x squared minus 8x plus 16. Once again, we'll rewrite this as 3x plus 4 times 3x plus 4, and use our standard FOIL method. Collect the like terms for a final answer of 9x squared plus 24x plus 16. Here we're asked to use common factoring. So a common factor between 5x and 15 is 5. So we'll put our common factor on the outside, x minus 3 inside. Our common factor for this question is 3. So that becomes 3 bracket x plus 4. This one, the common factor is 7, but since each term also has an x value, we have to consider the smallest x that's in all three of these terms. So in fact, our common factor will be 7x. Once again, we have in this question an x value in all three terms. So numerically, our common factor will be 4, and our smallest x value is a single x, so 4x will become our common factor. Difference of squares. Well, a difference of squares is recognizable when this is a perfect square, and this is a perfect square, and it's separated by a negative sign. So numerically, 5 is the square root of 25, and x is the square root of x squared, and 7 is the square root of 49. So factored becomes 5x plus 7, 5x minus 7. Over here, our square root is x, and our square root here is 6. So our factored form becomes x plus 6, x minus 6. Factoring trinomials. Here, we're looking for a number which will, or a pair of numbers that will add up to -2, but multiply together to be -35. And that pair of numbers happens to be 5 and -7. So our factored form is x plus 5, x minus 5. Here, what we should do, and we could have checked here, but it didn't apply, but here we also need to check, is there a greatest common factor in this? Can we reduce this using the greatest common factor before we go about using other methods of trying to further factor it? Well, in this case, we can reduce it by factoring it by 2. So we can say 2 x squared plus x minus 6. Now we can use our sum product method and look for a number that multiplies to -6 but adds up together to be positive 1. And those pair of numbers just happen to be 3 and negative 2. So we can write x plus 3, x minus 2. But we can't forget to bring down our greatest common factor and include this in our final answer as well. Fully factoring. Well, with these questions, we're going to have to do a combination of factoring. First, we're going to look for a greatest common factor, and then we're going to see if there's any other methods that can factor it further. So the greatest common factor between 3x squared and minus 48 happens to be 3. So we'll write our 3 there. Then we have an x squared minus 16. Now we look inside the brackets and see if we can factor this any further. Well, this happens to be a difference of squares situation. This is a perfect square, this is a perfect square, and it's separated by a negative sign. So we can say 3 bracket x plus 4, x minus 4. And this is our fully factored form. Over here, once again, we'll check first to see if we can reduce this a little further using our greatest common factor. And in this case, all 3 terms can be reduced by 2. So we'll put 2, x squared plus x minus 6. Now we're looking inside the brackets and asking ourselves, is there a pair of numbers that multiply together to be negative 6 and add together to be positive 1? And those 2 numbers just happen to be x plus 3 and x minus 2. And we have to remember to bring down our greatest common factor from the previous step. Here we're simply asked to complete a table of values. We're given our equation, and we're given the x values. So we'll simply plug in these x values into the equation to give us a pair of x, y coordinates. So take 0, plug it into the equation, gives us 0, negative 5, plug 1 in, 1, negative 8, plug 2 in, plug 3 in, plug 4 in. There's our completed table of values. Here in this question, we're given a new equation, x squared minus 4x. We're given x values of 0 to 4, which again, we'll just simply plug into our equation. Plugging 0 into our equation gives us 0, 0. Plug 1 in, 1, negative 3. Plug 2 in, plug 3 in, and plug 4 in, and there's our completed table of values. Here we're given a graph and we're asked to display the various features of this graph. So first we're asked for the axis of symmetry. Well, the axis of symmetry is simply the imaginary line that runs right down through the middle and passes through the vertex. The equation for that is x equals 2. Our zeros, or x-intercepts, are negative 2 and 6. Our y-intercept is 8. And our direction of opening, our y-intercept is 6. There we are right there, passing right through the y-axis. Our y-intercept is 6. Our direction of opening is down, and our vertex is 2, 8. Here's a second graph, and once again, we're asked to list the various parts. The imaginary line passing down through the center passes through the vertex. It's halfway between the two x-intercepts, and that is x equals 3. Our zeros are 1 and 5. Our y-intercept is 10. our direction of opening is up, and our vertex is 3, -8. Here, we're given a table of values, and we're asked to figure out what the first differences and second differences are, and then determine whether the equation is linear or quadratic. So 5 minus 8 is -3. 2 minus 5 is -3. -1 minus 2 is -3, and so on. Each of the first differences is the same. And this tells us that we're looking at a linear graph. Here's another table of values. We'll calculate our first differences again. -3 minus 3 is -6. -5 minus -3 is -2. -3 minus -5 is 2. 3 minus -3 is 6. 13 minus 3 is 10. So we can see that each of our first differences is not the same. So we know that our graph, illustrated by these plots, or these coordinates, the graph is not linear. However, if we calculate what our second differences are, -6 minus -6, and so on, we'll see that each of our second differences is the same. So this tells us that our equation, or our table of values, refers to an equation that is quadratic. Graphing using key points. So we're given an equation, y equals x squared plus 4x minus 5. If we factor this, we can figure out what our zeros are. So we're looking for a pair of numbers that multiply to -5 and add together to be 4. And this happens to be x minus 1, x plus 5. If our factored form is x minus 1 and x plus 5, then our zeros, or x-intercepts, are +1 and -5. Our y-intercept is simply this value right here, -5. Our direction of an opening is up because this is a positive value. And our axis of symmetry is this number plus this number divided by 2. So our axis of symmetry is -2. Once we know what this value is, this is the x value of our vertex. So once we know what this number is, we can plug it into the equation to figure out what the y value of the vertex is. And when we do that, we come up with a value of -9 for y. So our vertex is -2, -9. Here we're given another equation and asked to graph using the key points. Y equals x squared minus 8x plus 7. So to get our zeros, or x-intercepts, we simply factor this. We're looking for a number that adds up together to be -8 and multiplies together to be +7. Those two numbers happen to be -1 and -7. Now, if our factored forms gives us -1 and -7, then our x-intercepts, or zeros, are +1 and +7. Our y-intercept is simply this value right here, our b value. Our direction of opening, because this is a positive number, the coefficient of x squared is positive, then our direction of opening is up. Our axis of symmetry are our x-intercepts added together divided by 2. So our axis of symmetry is 4. This axis of symmetry of 4 is also the x value for our vertex. So if we know x is 4, we can take this, plug it back into our equation, and come up with a y value for the vertex. So if we plug 4 into our equation, we come up with a value of -9 for the vertex. So our vertex is 4, -9.